Okay, I think we should start. Just a small announcement to everybody: the presentations will be recorded. So if you don't want to appear in the recorded video, please keep your cameras off. So we will upload them in the CaSToRC YouTube channel afterwards for everyone to see. And just as a brief summary of the 2 days, so this is 2 days organized by the National Competence Center in HPC, which are devoted to the industrial sector. So it's mainly about artificial intelligence coupled with high-performance computing and how this can help your company or your organization go forward. And for that, we have the today's session, which is an introductory session. And tomorrow we have 2 training sessions, a morning one and an afternoon one. We have a Slack channel. I will post the link to our group chat now, so you can join. And we can also discuss there. And that said, we should move to our first speaker, who is Konstantia Alexandrou. She's a professor at the University of Cyprus and also the director of one of the centers of the Cyprus Institute, CaSToRC, who is going to talk to us about the National Competence Center in high-performance computing and the EuroCC project. Professor Alexandrou, please, you can start.
Thank you very much, Christo. I would like to welcome everybody to this event on HPC and AI for industry. I'm very happy to be able to give this talk today and tell you a little bit about the center and its activities as the HPC National Competence Center for Cyprus. Let me first start, if I can move on, tell you a little bit about the center. It is a computational-based science and technology research center of the Cyprus Institute. That's one of the 4 research centers in operation at the Institute. And its main task is to carry out computation-based research and education and provision of computational resources and know-how to the user community. So this has a dual role to carry research, but also forward it to the community of Cyprus, to the user communities of Cyprus. So it is with this latter role that CaSToRC has been designated by the government as the HPC National Competence Center for Cyprus. And within this mission, the center is motivating the use of high-performance computing, simulation, and data science to industry, academia, and government, and provides the infrastructure and support so scientists can use the infrastructure both in Cyprus, but also, and this is the goal, gain time on larger systems in Europe. And I will come back to this in the next transparencies. So infrastructure and know-how for compute and data in certain applications for the Cypriot user communities. So what is this project that we are going to be discussing here, and which is funding the events like the one we are having today? This is under the European High Performance Computing Joint Undertaking, which is a pan-European HPC action for scientific discovery and innovation across Europe. So the countries that you see colored are the countries that are participating, that have signed this joint undertaking. And you see Cyprus is one of them. Most of the EU member countries are part of this, but also associate countries. You see Turkey, for example, is part of it. Iceland, Switzerland, etc. And the idea, the first goal of the EuroHPC joint undertaking is to create a pan-European network of computers. These are machines, big machines, to be shared among all these states that are participating in the EuroHPC joint undertaking. And these are the machines I'm talking about that our National Competence Center would like the communities here to make use of. The second major action of the EuroHPC is the development of innovative exascale computing technologies, so that Europe does not depend on the US, Japan, or China for its computational infrastructure. So the project is funding the development of a European-based technology for big computers. It's a big project that is going on. And the third is to support entities like the Competence Center that we have for CaSToRC to increase the uptake of HPC by the member countries. So this third goal is what is funding, for example, the activities that we are talking about. Now, in the new framework program, the Commission has devoted 8 billion euros for the development of these activities. So a lot of money will go into developing HPC and applications of HPC and AI. Right, so where we are at the moment, as far as these three actions are concerned, so EuroHPC has already funded 5 petaflop machines, and the countries where they are colored in black here. So it is Bulgaria, the Czech Republic, Luxembourg, Slovenia, and Portugal. These are petaflop machines that is of the order of the machine that we have currently at CaSToRC. Our machine is about half a petaflop. These machines are about 10 times bigger. And these are machines that we in Cyprus can have access on, because we are funded by this EuroHPC initiative where Cyprus is part of. The plan is to also fund 3 pre-exascale machines. Well, it's not a plan, this is happening. These machines are being procured at the moment and installed. There will be one in Finland, one in Spain, and one in Italy, shown here in blue. And these will be machines of the order of 100 to 200 petaflops, so 2 orders of magnitude bigger as compared to what resources we have in Cyprus, so 100 times bigger. So this is why it's important that we can have access to these machines and be competitive in what we are doing. And the next step will be to procure yet a 10 times bigger machine. There will be 2 of them. One will be using this European technology that I told you about in the previous transparency, that is being developed using funding from European resources. And this, the expectation is that these 2 exascale machines will probably sit, one in Germany and one in France. But this has to be determined. Right, so coming up to the local activities, this is what the center, the activities of the center within this framework of the National Competence Center would do. So first of all is to raise awareness of the potential of HPC through such seminars that are given today and interactions of our personnel with the users in Cyprus, like like yourself. Then we have training programs like the one we're having this week with courses on HPC. We have a targeted event like hackathons where we sit with a company and discuss a particular code. And then we can offer hands-on on developing software, helping you to develop your software. I already mentioned this. We have a local machine of about half a petaflop, and this machine is accessible through calls for research and development freely. So you can submit a proposal. Actually, the call for submitting proposals is open today. So you can submit a proposal. The proposal will undergo peer review and be given resources on our machine, which is called Cyclone. And then we are procuring a machine that would be dedicated for industry applications. So not just research and development, but also for applications that do not want to publish the results, that are for becoming more competitive, that you may use to promote products or the services of your company. We provide consultancy for technology transfer and business development. Christos can contact you and we can discuss this with you. What are your needs? What you need for your company? How can we help for you to be able to use these computational resources for your advantage? We also can define co-development projects, both with academic group, but also industry. So if you have a project that you want to carry out with us, we can dedicate the personnel or have one of your people joining us here at the center, spending a few months with us so that we can help you to develop the project that you are interested in. So we are open to hosting people in internships if that something that will help you advance what business you want to do to be more competitive. And then we provide advanced user support to scale software that you may have so that you can access the machines at the European level, the machine that I already talked to you about. This, as I said, are much bigger than the resources that we can allocate to you in Cyprus. So, but you have to be ready for these machines because you have to have the software that are appropriate for using these machines, namely that they scale up to a large number of cores. And we have the know-how to help you do that. So the ultimate goal, of course, is to enhance competitiveness in research and innovation and be able to access these pan-European resources. This is the main goal of the whole EuroHPC undertaking. So with that, I would like to leave you, of course, with the people that you can interact with. Here is like the email is given. It's Jacob Fingerat. If you are from an academic or research institution, it's Kyriakos Hadjigiannakou for industrial and governmental organizations, and of course Christos, who is talking to industrial entities and trying to explain to them the advantages of using HPC. And you can also go to our website where there is more information of what we are doing. And with that, I would like to thank you for listening to me. If there are any questions, please go ahead. Christo, I guess we can take some questions.
Yes, we have some time for questions. So please, you can just open your mics and ask.
No questions, it seems to me.
No questions for now. Okay.
Okay, thanks a lot.
Thank you very much, Dina.
Bye-bye.
Bye-bye. If you hear me, I'm talking to the participants. Can you raise your hand using that Teams tool there? Okay. More people? Just want to make sure that you can all hear me. Cool. Now, can you put your hands down now? Cool. Now, one question: if you have used any form of artificial intelligence, so machine learning algorithms, or any other kind of, let's say, artificial intelligence algorithms, can you now raise your hand again? We have 1, 2. Cool. Now, last question, and then I start the next presentation. Are any of you here that you have used any form of high-performance computer? Maybe not at a high-performance computing facility. Maybe you have, let's say, a powerful workstation at your company or your organization or your, the institute that you are using it. Okay. Cool. Okay, thank you. That's nice. So now I'm going to now share my screen. Okay, here we are. Okay, now if you can see my screen, please raise your hand one last time. Cool. Okay, now, thank you. Now my presentation is more of again a motivation of why use AI and why use HPC and even why use them together. Yeah, the main purpose as CaSToRC, so we are advocating the use of high performance computing, and we try to stress its necessity for the future of companies that want to be at a competitive level, where intensive computation will be needed for their services or for their products or for anything that they do and they offer. So that's the motivation. And with that, let's start. First of all, my name is Christos. I'm working as an innovation scout at CaSToRC. My role involves building collaborations with the industrial and the governmental sector mainly, procuring the contracting process, meaning drafting the agreements with the companies, defining the projects, the deliverables, the milestones with the industrial government. So these projects need to mainly involve the usage of high performance computing, most commonly in conjunction with artificial intelligence, and let's say maybe less commonly in conjunction with let's say advanced modeling and simulation. And at least also one of my roles is together with the computational scientists here at CaSToRC, with Jakob and Kyriakos. We are coordinating such projects that are being carried out by the computational scientists here. So why HPC? From your hands before, I saw that there are not a lot of people that raised your hands when it came to have you used a high performance computing before. And to answer that, I would like to take a strong example where HPC showed its necessity during the battle for fighting against COVID-19. Probably never have supercomputers or high performance computers shown their value to society more than during this COVID-19 pandemic, where we saw that the massive computing power that is offered by high performance computing in combination with modeling and simulations and artificial intelligence constantly helped. And so from the beginning of the pandemic, and they continue to do that. So they constantly help scientists rapidly advance their understanding of the virus, of the disease, and thus leading to accelerated development of new treatments and preventative measures. So this is done, for example, by exploring the structure and behavior of the virus at a molecular level, forecasting the spread of the disease, and designing drugs much faster than would otherwise be possible. So historically, high-performance computing has been proven to be necessary to model and simulate complex problems and physical phenomena such as weather, fluid dynamics, molecular interactions, and so on. But now we see that, especially in the era of big data, we see that the use of high-performance computing has penetrated in a lot of businesses because it can help companies, organizations gain insights into areas ranging from let's say, genomics to financial risk modeling. So business can really leverage the computational power that is offered to them by these high-performance facilities to improve their products, reduce costs, and decrease time to market, which is of a significant importance for a company. So why it's important, especially now in the era of big data, these are some numbers from last year. So the average internet user produces 1.5 gigabytes per day, smart hospital 3 terabytes per day, and we go up to a connected factory, let's say, where we see the production of 1 petabyte of data per day. So well, it is safe to say that we are, as society now, we are quite greedy in the way we produce data. So there is a very big challenge in having too much data and not enough computing power or storage to gain new insights from this data. So usually we generate this data and they sit there without being further analyzed to gain more insights from them. Now, after talking about the why, so what is HPC? It's a combination of computing power from multiple nodes in a way to deliver much higher performance that one would get out from a typical laptop computer or a workstation, and that's in order to tackle large scale and complex problems in science, engineering, or business. So how does it work? So very high level. There are thousands of processors working in parallel and sharing information with each other, delivering more than millions of times more computational power than common laptops. How this is done? So as you would do with your computer, you prepare a question, you have a problem you want to ask, you want to solve, you prepare a question for it, you submit it to the supercomputer. The supercomputer you would take over, would break it down to multiple sub-questions, and then it would split that multiple sub-questions to multiple jobs. that would be shipped to different nodes and distributed to different processor cores. So high performance computing is really good at answering the same question over and over again. So the point is really having high performance computing is to have access to more powerful computation, so that you can parallelize, break the problem into small pieces, parallelize it, and come to an answer much faster than you would do by using a conventional computer, let's say. Now, having finished with HPC, moving to artificial intelligence, AI, for short, is important as it enables human capabilities or human-like capabilities like understanding, reasoning, planning, communication, and perception to be undertaken by a computer, by software at scale, and increasingly effectively, efficiently, and at low cost. Now, going to the question of what is artificial intelligence. So it really refers to the simulation of human intelligence in machines that can be programmed to think like humans and mimic their actions. So you can see a very well-known figure on the right, where you can see the artificial intelligence is the big umbrella covering the fields of machine learning, which is an umbrella covering the field of deep learning. Now moving on to how does artificial intelligence work, talking specifically about machine learning. So what do you do in the case of machine learning? You provide loads of data to your program and the answers to this data in most of the problems. And your software comes up with the rules to use to solve these problems. If you compare it with the traditional programming methodology, what you would do in that case, you would give rules and then data, and then you would expect the traditional software, let's say, to come up with the answers. And the problem with that approach is that it becomes really time-consuming to come up with these rules, and it's much easier to let the computer come up with those rules. So again, in this picture, it talks more specifically about supervised learning, which is one of the subfields of machine learning, which has to do with the problem that you have the answers for. There are some supervised kind of problems where you don't have the answers for this problem, and you're expecting from the machine to come with the rules just by exploring the relations and features within the data. Having talked about machine learning, going now to deep learning. As said before, deep learning is a subfield of machine learning. In the, let's say now, traditional machine learning approach, what you would do is you give an input, which is the data. Then from that input, you would again need humans. At least this is now a semi-automated procedure, but we would need humans to extract features from this data. So understand which features from a variety of features that are contained in this data are important for the problem at hand. And talking about the, let's say, classification problem in general, then you give these features together with the data to your, let's say, classifier, and then it would come with an answer for you. Now, in deep learning, the human is being moved a bit, again, away from the picture, since the feature extraction is now being taken care of by the deep learning model in most of the cases. So you give the data, and then you wait for the deep learning model to come up with implicit features or implicit representations of this data, and then features for this data, and then come with an answer. Combining this all together, and of course with modeling and simulations, we see that a lot of mainly scientific fields like physics, astronomy, chemistry, engineering, material scientists have traditionally used HPC to conduct research and solve complex problems. Some traditional workloads come from genomics, molecular dynamics, and now increasingly financial data, cybersecurity, climate data, and so on. Nowadays, we even see social sciences like humanities and an increasing number of more industrial fields use high-performance computing, again coupled with AI, to solve the complex problems in their field. So what this shows is that the uptake of HPC from all these different fields really shows that people want to solve more complex problems as times go by, and so the need of computational power increases. Now, taking now some examples of where AI coupled with HPC has been used. I'm taking again the example of COVID-19, where these methodologies have been used as to screen and identify compounds that can fight the virus and the disease. They have been used excessively to test interaction between these molecules and active sites of the virus, so that they could use them as to develop new drugs to tackle the virus. And the HPC came into the picture as it helped accelerate the discovery of this compound. So one project, it's called Exascale for COVID, could simulate 5 million molecules per second on one of the biggest and most powerful industrial supercomputers in the world. Nowadays, we see consortia being built to fight COVID-19 using high-performance computing. We see high-performance computing together with AI being used in banking. So we see now banking and finance sectors need to solve a lot of complex problems coming together with a massive amount of data. An example is risk assessment, where new regulations require more detailed models. And this necessity has led to the creation of many computational intensive tasks that require the use of HPC to be solved. So many firms are seeking to become data-driven businesses by taking their growing data sets and finding insights to be ahead of the competition. Another example comes from the overall need for digital transformation now being developed by many companies and organizations. Example are fields like natural language processing and computer vision, where these fields can help the automation of various problems and help industry and government in their journey to digital transformation. So these tools can be used to translate languages. They are used as voice-to-text conversion, create human-like conversational agents, classify or detect objects in images. You can think of self-driving cars or other computer vision approaches. And a lot of applications in industry and government is to automate administrative work, build more intelligent products by the use of this software, and even optimize internal operations. We see now that, for example, these language models that are now a very hot topic in the field of AI. We see that the way that they increase in terms of models, as for example, if you count the number of parameters that exist in these models, they increase much faster than the growth of GPU memory improvements. So what this implies is that to, let's say, train a new big language model that will be able to say, let's say detect some semantics in a language or emotions from a text, you would need horizontal model parallelization than a vertical one that would be used that has been used until now on the same machines. So this is why high performance computing, where you parallelize the workload, becomes important. So summarizing, AI coupled with HPC for your businesses can be used to improve your business workflow in a lot of fields. You can improve your products by having more experimentation and by having faster iterations. It can lead to a lot of cost savings. So if you have big data sets and complex problems that you need to solve, you can use shared infrastructure without the need to invest in high performance computing equipment. At least you can do it at a prototype level and then see whether it would make sense to do the investment. But as Professor Alexandru mentioned before, our aim at CaSToRC or at the Cyprus Institute in general is to have a group of nodes, so a part of the HPC facility here to be only for industrial applications. So that would be for your benefit, as well as it would provide a lot of cost savings. In terms of business agility, again, as with improving your products, you get a faster time to insights as you have the computational power to work faster. And lastly, this can lead to a competitive differentiation as you can speed up your workflow and decrease the time to market for your products or services. So living in an era where competitiveness is also a factor of the speed that you move forward, HPC can be of a lot of help with that. As talked before, you can have a competitive differentiation by using HPC, since this has been also seen by many companies in Europe and US and in other parts of the world. Adding HPC would accelerate your machine learning, deep learning model training and inference time. So if one company would manage to accelerate the slow parts of let's say the artificial intelligence pipeline, which one very lengthy task is the training of the whole model, that would accelerate the whole workflow. And on the other way around, AI can optimize itself HPC workflows. So together, this would enable companies or organizations discover insights more quickly, allowing them to adapt and respond to changing business conditions. Again, this is a matter of being fast. Closing, what can you do for your business or organization? So if you have a project that you believe that is computation intensive, you can contact us at that email or fill in that form, which is an expression of interest form. And we have some, in the HPC facility here at the Cyprus Institute, we have some computational time that we can reserve for industrial applications or industrial prototyping, where we can reserve that time to work with you to try to automate part of your workflow or make part of your workflow more intelligent. That can lead to added business value for you. And of course, we will listen later to the industrial collaborators, where we have some projects running with them to talk about how they believe that HPC together with AI adds value to their businesses. And with that, I would like to thank you. And if you have any questions, please open your mic and ask. No questions? Okay, then we can move forward to the next talk by Kyriakos. Kyriakos, are you in the audience?
Yeah, I'm here. In just a moment to switch on also my camera.
Okay.
Hi everyone, so let me start sharing.
By the way, just to add until you Kyrako start, you can also shoot any questions you have in the Slack channel we have. So I've shared it in the Teams chat. You can go to general channel, and if you want to ask any questions later, please do so. And if you want to contact us there, you can contact us via Slack. Thank you.
Thank you, Christoph. So, do you see my slides?
Yes.
Okay. So, good afternoon, everyone. So, in this presentation, I will tell you about the support opportunities that we provide for industry within our National Competence Centers in HPC. So in an advanced society, we have different institutions that they should work together for the prosperity of their citizens. We have, on one hand, academic institutions, and they produce knowledge through the research that they are doing, but they also educate people. And we have also the industries that they can hire the graduates from the academia and use the knowledge produced in order to do innovation. And we have also the government organization that one of their role is to support academia and industry in their effort, but also they need from academia and industry some support in order to adapt to this digital transformation. So here in our competence center, we try to bring those organizations together under the umbrella of advanced computing. And when I say advanced computing, I mean HPC and also advanced algorithms, that those involve also AI algorithms to bring collaboration, and hopefully this improve the effectiveness of the individual institution. Okay, now I would like to go to more details about the support opportunities that we provide. So one service is we provide consulting regarding the HPC and machine learning. So we have a high-level support team. And this service is for free, and I will tell you more details about how the procedure works. So we can sign between a company and her center a mutual agreement, and after this agreement is signed, we can have access to the software. And it is preferable if this is an open source, in the sense that we need to inspect it in order to be able to provide some consulting. And the next step is that we do some tests in order to understand the bottlenecks of the software from where they come from, and suggest solutions and see how this can improve. Another step is that we check what are the algorithms that have been implemented and the idea behind the workflow of the code, in order to find sectors where we can do parallelization in the software, and this may allow for speed up the software or even scale up, if this is possible. And based on the demands of the software, we may suggest what architecture can be used, like multi-core CPUs, or CPUs that can have many cores, or GPUs, graphic processing units. And we also examine the possibility that if the software has some is doing some predictions and is using some data to learn, so we can incorporate machine learning, of course. And as last is now we don't have still so many data, produced from companies in Cyprus, but the trend is that this will exponentially increase with the years. So more and more applications will need to use distributed computing to have enough memory for analyze such big data. And this is something that we can also support. Okay, so other services that we have is that we organize training events in the area of advanced computing and machine learning. So those events have the goal to increase the awareness in our country about these important areas, and of course are free of charge, and we have identified different levels based on the experience of the users that we may have. The first event took place in February. It was about it was a beginner event. We had the intermediate in April, and we had several people who participated, and the events have been recorded. So in those links, one can go and find the events again. And tomorrow we'll have in the session, they will have training sessions about machine learning and porting codes to GPU. And of course, we would like to have also other training events, so will be announced in the near future. And of course, the feedback is very important because we want to improve the training and of course, maybe specialize it or also enrich it. Okay, other service that we have is that it will have a company that they express to have a project we have. Of course, we discuss the project, what kind of project could be. And again, after we may sign some agreements between our institute and the organization, and identify the project, and the company can suggest a person from their staff who is more capable of the target project, and then we can provide financial support to that person or persons. And this participant to this program will be co-located to our center, and also the company, if it's an employee of the company, for a duration of 3 to 6 months. Of course, this depends on the project. And then we will assist those members from our high-level support team. They will get access to our HPC resources that might be needed for the project. And of course, they can get experience in this field through the involvement on the project. Okay, I will say a few things about. Sorry? I thought I heard a question, but okay. So here I will say a few things about how the form that a company can fill in order to express interest to have a project with us. One can give an email address or can contact them, the name of the company or organization we're talking about. You can suggest members from your staff to involve in the project, and of course, a small description of the project. For example, what are the computational requirements, the size of the data, what algorithms are used, or the programming language, and of course, to give some technical aspects if you need licenses or you need some special kind of libraries to use it. Okay, the financial support that I mentioned before from our center for those projects. And yeah, you can choose also more kind of support that you may need if you need training or any other kind of support from us. And another service is that we have computational resources. So in our institute, we have the biggest machine in the neighborhood, which is called Cyclone, which has a 600 teraflop peak performance. So this machine is equipped with two different kind of partitions. So one partition that it's only composed from CPUs, so we call those CPU nodes. We have 17, and another one which is a GPU partition. So it has CPUs and GPUs, and it has 4 GPUs each node of a Volt architecture, each one with 32 gigabytes. So in total, 128 gigabytes per node of GPU memory. So for those that they have a large data set or they need a lot of power. And I would like to mention that those GPUs are very good for machine learning. So we have a lot of storage that one can use in a relatively low cost. And those nodes that we have on this machine are interconnected, and this connection is very fast, so which is something very important when one wants to do distributed computing, and it involves communication. Okay, as a last, we have the service that we can do a co-development of a software which might have an HPC or an AI aspect. So again, we identify those projects in collaboration, and here it's important that we have an agreement in order to specify the duration of the project. But because this service is not for free, we need to also specify the cost of the service. And of course, you can take advantage of the internship program that I mentioned before, that we provide some financial support. And based on the kind of the project, we assign the appropriate person from our high-level support team to work on this code development. So an example is a project that we have with a company called Offshore Monitoring, active in the maritime sector. So they want to optimize, for instance, the fuel consumption that they have for ships that they have doing trips, for instance, for taking products from one country to another. And there they have the optimizer to optimize those trips, but of course they can become slow if you have to optimize a very long trip. And on CPUs, this becomes more and more difficult. So we are working to incorporate more advanced computing architecture like GPU on the software. Okay, so this is an overview of the services that we have. So of course, we will need your feedback in order to improve those services. This is very important. Now, as I said, the consulting is for free, so please take advantage of that. And we have the internship program that we can provide financial support through this program. And about the training that we provide, we'll need also feedback. And about the resources, as I said, we have Cyclone, but we expect to have soon a supercomputer dedicated for industrial projects. But up to now, one can get familiar with the HPC environment by accessing through the preparatory access Cyclone. And of course, we are open for projects to do code development. So thank you a lot for your attention. And if you have questions about the services, please go ahead.
No questions? Okay. Thank you, Kyriako. If you have any questions later, again, I remind you, you can shoot them in the Slack channel. Our next talk should be Professor Vangelis Harmandaris, but he's a bit late. So let's proceed with Andreas Afandidis. who is here he is, from NovaMechanics. Andrea, we can see your screen.
Okay, can you hear me?
Yes.
Okay. Thank you, Christos, and all the organizing committee for the kind introductions and the opportunity to present our company and our work to your workshop. I'm Andreas Avandilis. I'm the managing director of NovaMechanics. NovaMechanics is an SME. Was founded in 2000. In 2005. One moment. Okay, now it's better.
Yes, now it's full screen. Yes.
Okay. Okay.
Thank you.
Okay, perfect. Okay, 2005 until 2009, we were building the CV of the company, and in 2009, actually, we have started our activities, and then we have managed to get the first project on applied drug discovery. At this stage, AI was not so development, but at this stage we have used machine learning for the discovery of novel inhibitors for Alzheimer and rheumatoid arthritis. Also, we have participated in many European and US funded projects, and also we have managed to get the first commercial customers. Basically, were some contracts for developing machine learning models for the prediction of MEK inhibitors. We have continued through the years, and I would like to highlight 2009. In 2009, we have managed to be a coordinator of a very large European project. I will say a few words in the next slide about that, NanoSolvit. In 2020, we have released our ESA loss analytics platform. It's a platform with AI capabilities and machine learning. And also we have launched our database solution, and we have become major contractor for several European institutions. In 2021, we have became coordinator of a second Horizon project. I will say also more about it in the next slides. Currently at the company, we have 15 personnel, 10 of them. They have is a multidisciplinary team of PhD holders who have produced more than 90 scientific publications, and who have participated in more than 25 research and development projects. Our area of research is around chemoinformatics, personalized medicine, and nanoinformatics, and in all of these areas, our contribution is the development of silico services and tools, of course, with the contribution of artificial intelligence and machine learning. This is a representative list of selected drug discovery and material science projects. Some of them are funded by the European Union, others from the Cyprus Research Promotion Foundation. We have a strong presence, especially in nanosafety projects, and we have participated starting in FP7 and in nanomile, and finally within Horizon Europe, we have participated in seven more Horizon projects, and we are coordinating 2 of them. In the majority of the project, we are using artificial intelligence for the modeling and the simulation of the phenomenon related to nanomaterials. NanoSolvit is the first project that we are coordinated. It has 24 partners. There is a strong international presence outside of Europe. We have 16 European partners, but we have also 8 partners from outside of Europe. We have partners from United States of America, South Africa, Australia, South Korea, and Japan. And the second project, the ComSafe Nano, have 16 partners from Europe, and we have 6 international partners from Canada, Brazil, South Africa, Pakistan, South Korea, and Japan. An overview of our products. All of our products, I would like to highlight that can be linked with HPC facilities, and also they are using AI or machine learning behind. We pay special care in order to provide a graphical user interface, a friendly graphical user interface to the user, so it's not necessary to the user to have any deep knowledge of AI, of machine learning, and with some simple steps they can build a model, or they can use an already developed model. We have the Pharos database solution. Pharos database solution consists of 3 modules. ChemPharos is for chemicals, MedPharos is for the medical applications, and NanoPharos is for the nanomaterials. The ISALOS analytics platform, there is also a workshop tomorrow that will have the opportunity to learn more about ISALOS analytics platforms and run also some machine learning models. And Enalos Cloud Platform. Enalos Cloud Platform has the capabilities to export as a web service any model that has been developed with this analytics platform, or any other platform that follows specific requirements. Enalos Plus 9 nodes are running under the NIME environment, and of course we are working currently. Enalos 9 are fully connected with our appropriate computational infrastructure, but we are working also in the direction to link and then connect them with Cyprus Institute's HPC services. For example, the user to select if they would like to run the calculation locally, or if it is a big data set, for example, can send it to the HPC and receive it back. The same with Enalos Asclepios 9 nodes. These nodes are dedicated for drug discovery applications. As you know, many of them are time consuming. I will show some slides later on about that. And through the Enalos Asclepios 9 nodes, the user can organize drug discovery workflows and run them either locally or send them to the HPC for calculations. A closer look to ISALOS analytics platform. The user can see front and graphical user interface, but behind there are several algorithms and tools, all of them integrated. We can say that our model is to move the algorithms and not the data. Currently, there are quite a good number of papers that they have used ISALOS analytics platform for the development of machine learning models. How NovaMechanics currently is using the HPC services. We are performing molecular talking calculations. For example, when you have a small molecule and you would like to investigate the binding energy at a protein binding site. The protein is the receptor, the small molecule is the ligand, and you can perform the docking experiment and investigate the binding site, the behavior of the molecule in the binding site, and the binding energy. In order to speed up these calculations, we have created a wrapper for the RxDoc software. This wrapper is ideal for the HPC for HPC calculations. In order to give you an example, when we were running before the creation of the wrapper, for example, we would like to screen 13,000 ligands. We need approximately 7 days, but with the use of the wrapper at the Kiklon server, when we have the opportunity to use 100 CPUs, we need only 2 hours. This is especially very significant when we need to have very fast decision and also to proceed to the next step in the application of the molecular dynamics simulations. Currently, the HPC unit offers a variety of programs. For our work, we are using mainly LAMPS and OpenMM. There is a significant also speed up to the calculations using LAMPS. For example, we are using LAMPS for the cooling cycle of nanomaterials in order to generate amorphous nanomaterials, and also we are using OpenMM as an output from the talking calculations. And for systems with 70,000 atoms, we have the opportunity to perform simulations of 250 nanoseconds per day. Thank you for your attention, and I am open if you have any questions.
Thank you very much, Andrea. Again, if any questions, please open your mic. So as Andreas mentioned, we will have one of the morning training sessions tomorrow will involve using the Isalos platform, where you can see how you can build part of a machine learning pipeline with virtually no code, just by using some blocks, let's say. So it's a visual way of constructing machine learning workflows. That's tomorrow at the morning session. Okay, if there are no questions, the next talk is by Professor Vangelis Harmandaris, professor at the SimEA ERA chair project, who is going to present to us about the SimEA project. Vangeli?
Can you hear me now? Hi.
Yes.
Hello. Thank you very much, Christos, for the introduction. So just let me share screen.
Andrea, maybe can you stop sharing? Okay. No, that's not the problem.
Can you see now?
Yes.
Okay, can you see in full screen as well?
Yes, perfect.
Okay. Thank you very much. So, hello everyone. So actually, in the next, let's say, 10 or 15 minutes, I would like to give you a short overview of our project and a new initiative that we have started since last year at the Cyprus Institute that is related with the computational science and engineering, and it's a European research area chair project that is implemented at the Institute. So the goal actually of this project, it's within the general, let's say, scope of what is called computational science and engineering, which, as you see here, is by its definition an inter or multidisciplinary, as we say, field, since it involves all kinds of physical sciences and engineering, together with mathematics and models and methods, and of course computing and computer science as well. And in the overlap of all this, the computational science and engineering, typically we say that this is within the triangle that involves computation, theory, comparison with experiments as well, and we have here this coupling, and of course this is going together with computational infrastructure. So computational engineering cannot be done, of course, without the infrastructure. And actually here it is. Oh, sorry, here it is. I think this is currently the largest supercomputer in the world, which is in Japan, Fugaku. And at the same time, there is also a smaller yet very good machine also at the Cyprus Institute. Okay, and now as a general again remark, the computational science and engineering concerns, let's say, two branches in this evolution of science. It's quite often is represented qualitative picture where, as we see here, science was empirical for several thousands, let's say, years. In the last few hundred years, we have this theoretical branch started with the modern, let's say, physics and engineering and the physical sciences. And now till about 50 years ago, when the computational infrastructures have been invented, let's say, for the first time, the computational branch and the simulations of complex phenomena started to be a new part in order to actually understand, let's say, the world around us. And now the last 10 or 20 years, together with these different branches, we have also what is quite often is called data exploration, so it is, or data science. So we have all these advanced data management, statistics, and algorithms. And this now is referred as like the third here and the fourth actually pillar of scientific discovery. And now the SimEA, the Simulation Engineering Applications Initiative concerns actually the modeling and simulation, as I said before, for in all this level. And these are just some, let's say, historical concept about the project that has been officially started, let's say, as the project 2019, but as the research group has been funded on July 2020. And there is actually for around 3 and more years till the end of the project. And actually the main scope, I would say, of the SimEA is to create a new, based on this new initiative, to create a new team at the Cyprus Institute with, in order to build collaborative schemes with other places in Cyprus, but also in the European level, and not only with academia, but also with public and private sector, collaborative schemes, again, on several aspects of computational engineering in order to let's say, use advanced computing and data science methods to solve problems in science and engineering. And together with these, let's say, collaborative schemes, a main goal is also to create a computational engineering hub. And actually part of this hub are also the activities that we all attend, let's say, today. And structural changes at the same time at the level of the Institute. And this is actually just a very short overview of the research team, which concerns, beside myself, of Assistant Professor Nico Sava, an applied mathematician. And then we have postdoctoral researchers, Panagiotta Katsamba, Petra Bachova. She was actually here till, let's say, couple of months, and Aves Mahmoud, who are, let's say, they are researchers, they are senior researchers from different, as you see here, branches, from applied mathematics up to molecular simulations and chemistry, and also from the fluids and interfaces in the atomistic and continuum level. And there are also 3 PhD students who are also coming from different background, engineering and applied mathematician, as you see here, Nikolaos Patsalidis, Eleftherios Christofi, and Pavel Serva. And part of this actually of our team is Christos, who is the key person in creating this innovation hub, as we said before. And there is also Kathy Christoforou, who is our scientific coordinator. So as you see already, there is a very well-developed team, and we are very glad about that. I'm very happy having all these nice people to collaborate with. And here now concerning, let's say, the research directions and themes of the project, that's just again a very short overview. So as you see here, our research concerns what we call multi-scale modeling of nanostructural materials. These are materials with different phases, different components, and because of that, they have a very complex, they appear a very complex behavior. and also developing and implementing new methods, which, as we said, typically they are physics-based, data-driven approach for the simulations, and also besides the nanostructured materials, applications refer also to biomolecular systems, and also to statistical methods for uncertainty quantification, model selection, and of course, all these are coupled always with the high performance computing and AI, as we say, technologies, which is our software codes and scale up the codes, and in order to take advantage of the large infrastructure, and especially for the computational modeling now and what we call multi-scale simulations. So typically, this can be described via such qualitative plots of length and time scales here, and here you see different techniques that can that refer to the modeling actually of a system in various length and time window here, from the more detailed, which is the quantum level, up to what is called here classical, microscopic, atomistic simulations. Here we have mesoscopic simulations of coarse grain, and then we have here the continuum elements like finite, the continuum level like finite elements, for example. So this, as we see here, there is broadly a family of methods, and in all cases what we're trying to do is for the same system to use multiple techniques across various scales in order to simulate the material and predict the properties, and predict as well structural properties relations that can be used in order to help, let's say, for the design of materials. And this actually is part of what is called here computer-aided design of materials, which is very important from the technological point of view. So our goal is to help actually the industry, let's say, but as well as from the basic science point of view, to develop new materials with the desired properties. And just here to give you a couple of examples. So one example is concerned polymer. One example is polymer nanocomposites. So polymer nanocomposites are used actually in our everyday lives. And the main idea behind them is that we add inside the polymer matrix, we add some dispersed phase in order to enhance or modify the properties of the hybrid material. And actually, these are very successful, let's say, materials that be used in many different here areas, from, let's say, catalysis or information industry to energy storage to transportation, also the biomedical now sector. So nanocomposites are used really every day. And as you see here, also tires consist of polymer nanocomposites. And because of that, it's extremely important to predict their properties. And this is a typical example of this multi-scale idea. And actually, this is also in a collaboration with an industrial here partner. And the idea here is that someone can start from the atomic level, where we combine, let's say, simulations with data analytics methods based on also experimental data, and from that to design, to predict the properties of the material, and go up to the engineering scale where someone's, let's say, the goal is to design a new material. And so you see here an entire, actually, the entire route, let's say, from the chemistry and what happens in the atomic level between atoms, molecules, and we have the dispersed phases, the interfaces, up to this nanoscale, as it's called, and to the mesoscale level, up to the engineering scale. And the idea is to, as I said before, to combine simulation techniques with available experimental data in order to predict the properties in that level, which is close to the production actually of the material. Okay, and another example now of a different project that was again a collaboration of several partners. This concerns now the modeling from our side. The goal was the modeling and the simulation of biocompatible systems. And the idea of the entire project, it was to get actually from bio-waste to create bioplastic, which are polymers, however, biocompatible, that can be also, can be recycled. And in that case, as you see, we start again from the atomic level, from the simulations and various levels here in this multi-scale idea, in order to predict the properties of the material. At the same time, we had the collaborators here who were doing the real synthesis of the material and also the route from this bio-waste to the biocompatible materials. Okay, so these were just a couple of examples, and just as, let's say, a last part, but very important, is that part of the SimEA is also, as we said, in the center level, in the CaSToRC, but also in the Cyprus Institute, to create here these innovation actions, which are going together with the EuroHPC project, since already the center is a National Competence Center in the high-performance computing, and at the same time to provide a service portfolio tailored to industry, academia, and public administration. And of course, as we said, all this they can be done, let's say, together with the necessary infrastructure, and that is actually the supercomputer that is at the Cyprus Institute. And as we see here, our main goal is to, in general, to advance the competitiveness in research and also the engaging with industry, which is of course very important for what we discussed today. Yeah. And now, especially the Management Innovation Office, I would like just to close, let's say, this part with that, and to give you the message that we have here, beside Christos and Kathy, also other people like Andreas Gavrilidis, who are helping us as a scientific coordinator of the center. And we have, so with all these people, we have created this Management Innovation Office, which main goal actually is to create new links between academia, industry, and government, using the current expertise at the Cyprus Institute on high-performance computing, artificial intelligence, the simulations that we have seen before, and in general, all the expertise that there are now. And we've seen that actually via this, as you have seen probably from Christos, there is a series of activities that are going together with that. Okay, so I think I will stop here. As a final part, there is something about the market analysis, but I think, Christos, you have probably already mentioned that in one of your previous talks, if I'm not wrong. So thank you very much, and I would be glad to answer any question that you might have.
Thank you, Vangeli. We have a couple of minutes for questions if anyone wants to ask.
Actually, Christos, if there are not any questions, we can. I'm not sure if you have presented this.
I have not presented that in the presentation today. No.
Today. Okay, good.
I have not. So you can.
I have not. Sorry, I thought that you have. So, is there any question? Just so, this was actually a market analysis performed primarily by Christos, where we have seen, surprisingly, at least from my side, that the increase, let's say, of the companies involved in data-driven activities and engineering design in the national level, they are increased dramatically during the, let's say, from 2016 till 2018, where we have some data. And also the companies in Cyprus that they utilize computing power, as we can see here. So this increase, let's say, from 45 to 180, so 4 times within 4 years. I mean, it's really amazing. And this shows exactly that how important this, even for a small country like Cyprus, we're a small place, but how important actually is nowadays to use and to take advantage of the expertise that exists on high-performance computing, on data, and on AI, together with cloud services for the software. Finally, this was the last one. Sorry for this. This was the last slide, and here actually is the computational infrastructure at the Cyprus Institute. Without the computational, without this, yeah, nothing of the previous could be performed actually. And just to say that again, I'm sure that you will hear that within, let's say, this session today, that there is opportunity for companies as well to write projects in order to take some computational time at the supercomputer in Cyprus Institute. Okay, thank you very much again. Any question?
Okay, thank you, Vangelia, again. And
Okay.
I think it's 4:30. We should proceed to the next presentation. It's going to be by Thomas Dimopoulos from Axia Valuers. So where we also are collaborating on a project where we use real estate data, let's say, for mass appraisals. So for evaluating the property or for predicting the property value. Thomas, please go on.
We cannot hear you.
Hi everyone, my name is Thomas Dimopoulos. I'm a lecturer at Neapolis University and also visiting lecturer at Cyprus Institute of Technology, but I can describe myself more as an industry person rather than an academic or a researcher. Now, with the assistance, first of all, I will continue to where the previous speaker left. Like he encouraged companies to use all the possibilities that this supercomputer offers to us. So this is what I'm trying to get advantage of a project that I'm preparing. So what is actually this project? This project started with a completely different direction. It started as you know, my work in the industry, I'm into the property valuation field. So we are the interim person, the property valuers are the interim persons between the lender and the bank, the lender and the client who gets some money to buy the property. So they need us to verify property values. But the problem again in my field is the data visualization, the data process, and how to verify data, how to verify the sales, how to visualize these sales. So someone who doesn't know the market or the real estate, or it's outside the real estate industry, would be able to understand and follow what the valuer is saying on his report. So we have a company who is doing property valuation and another company who is developing a software for valuers. Mainly, it started just to visualize the comparable evidence with the use of GIS technology. As it started, this software wanted to do something more than the typical Excel that the vast majority of the valuers were using. We believe because in real estate, the location is the most important, the most influential factor of value, that map integration in GIS, because seeing is believing. Okay, so we need to show all the comparable evidence in a map to the valuation viewer. So what we created here, database queries that will be represented on map, some tables, graphs, exports on map, and we offer cloud storage of every different valuation company or property fund, cloud storage. So far, our main clients is Altamira and Gordian. So those who are based in Cyprus, they know these two major big companies who are using this software. So this was the first step. Together with Dr. Bakas, who is among the panel here, he insisted that we should move forward and do some calculations, not a simplistic way. We do the calculations with a comparative method and adjustments, and advance the way and the software by using machine learning and artificial intelligence technology algorithms, so we can predict the values more accurately and faster, definitely faster. Because in the valuation, very, very important is the time and the cost of evaluation, because valuers need to travel a lot of kilometers then to prepare the report. So it's a time and money consuming job. So we're trying to solve this issue with this software. Someone just, I'm hearing myself, probably Daphne, who just entered, to mute herself. Thank you. So the technology behind this software was like PHP and JavaScript for the web page, Ionic framework for the mobile app, and the database PostGRE with PostGIS extension, and we use the servers. Nothing special, nothing very complicated and difficult. However, because the database for properties in Cyprus and globally, issue globally, but in Cyprus, to be more specific, where this software is based, the problem that we have is that the data are not enough, are not clear. So in some case, we need to create some data ourselves. So every property transaction is recorded from the Department of Land and Surveys. Registered valuers are buying those data, but those data are not very rich in content. So let's say someone is buying a parcel of land, but the frontage of the land, or if it has road access, is not recorded. Additionally, the planning zone is not on this file, so I need to use another database and combine the database. So all these issues need to be solved, and we need to create more data to enrich our database. In that case, when we were trying to use like conventional computers, for Cyprus, which is a small island, actually half an island, a conventional computer with i7 processor, Intel last generation, it will take like approximately a week to do the calculations on the GIS, to run the query and see if there is a road access, distance from a registered road, the frontage of the parcel, etc. So this is why, with the use of this Cyclone supercomputer, we are doing this kind of calculations in a couple of hours. And later on, I will describe my experience with the Cyclone. So this is what again the technology with the software. Someone to access the software and not the calculations behind, just need internet access and a web browser. And the cost-benefit analysis of this, some workflows of the software, the visual representation. So the aim is to make this software richer and not only represent the existing, the former transactions, the past transactions on the map, and filter the map per category, let's say flats, parcels, plots, coastal area or in a specific area, do the research like that, but to predict also the values of a new parcel. So therefore, more data were necessary. So this software is also doing some property analytics and offers market intelligence to its users. Things like that, like the areas, so the developer would know what to build, what is the area, the range of prices that he can sell based on a specific location or in a whole district or in the whole island. So this is what the software is doing. Regarding my experience with the Cyclone, I would say like this started like 3 weeks ago, and I can say that the environment is very, very friendly. Sorry, just give me a moment. There is something wrong with my computer. So, and the documentation is very, very clear, easy to follow. Had several issues because at the beginning we couldn't use like many cores of the processor, so very easy, like we created some ticket on the problems we faced, and we're talking about like that because I'm not like the super keen person in programming, and I could solve all issues by myself or by my team. So the support service was very, very efficient, and the help we received was super valuable. The options offered to access the Cyclone were very, I felt like working in a very secure environment. Additionally, following a job status was very easy and convenient. The other issues that I need to install some additional modules regarding the post-GRA and the post-GIS software that I was using, and some Python, was also very, very simple to install some new modules, despite the fact that the available modules were a lot. And last but not least, the assigning resources to a job was very straightforward. So I think the guys at the Cyprus Institute made this tool very, very easily accessible to the public. And for someone who has like a small company like me with not a lot of experience, without being very experienced, so we're able to use and getting advantage of all these capabilities offered. These are the things I had to say. So far, I'm very happy. One kind request that would be to use like more than 24 hours sometimes, because some of the procedures are stopping and we need to restart again from the beginning. But so far I think that having in mind all the previous problems that have been tackled in some working hours, I believe that we'll be very soon have very sound results on what we want and with the use of this supercomputer. Thanks a lot for your attention. I would be very happy to share like more insights of the projects based on your questions, if you have any.
Thank you very much, Thomas. So, yeah, question, Nico, go on. Nico, you are muted.
Sorry. Okay. Hello, Thomas. Thank you very much for the presentation. As far as I know, the software is very innovative for Cyprus, and I would like to highlight some the innovative aspect of the software and also our collaboration now for machine learning. I mean, what is the purpose of the project, something like this?
Yes, like many of the ideas, the mastermind behind of these ideas is Dr. Bakas. So he was, when I was sharing my enthusiasm about the software and what the software is doing, Nikos was always like very skeptical. Yes, it's good, but what if you could add this? What if you could do the other? Because of his specialization on these automation things. So with this software, Nikos, we aim to minimize the cost of evaluation, and having like a 24-hour tool to produce and forecast values on a specific areas and of a specific property type. And for that, the problem so far is a problematic existing database, and that we need to create more data ourselves, and this is why we're using the Cyclone. And the innovation is that it would be a very useful tool for the public, for the banks. Also, it will assist the whole market by increasing transparency. So someone who wants to buy a property, he would very easy set a query to this platform, and this platform, when finished, it can be like a plug-in to an existing estate agent, to a bank website, to an investor, to a property fund, to Cyprus Investment Authority, somewhere. So someone should put like the basic features of a property and could predict the value with the price range automatically. Because if it is like a complicated property, you need like minimum 4 working days to complete the valuation task. Because you need inspections to get all the information, to view the property. So with this, you need like just seconds, but we need to enhance the database, create some data from GIS to enrich our database. So the results would be more sound,
Thank you, Thomas. Nico?
Yes, thanks. Yes, actually, I wanted Thomas to talk a bit about this because it is very innovative. It is like, especially for Cyprus and also other countries, there are a few industrial applications of machine learning in real estate. So I guess it is an interesting project.
There are mainly in the States, in the UK, in Germany, already exists, and we're trying to implement it in Cyprus, but we have like different sources of data, and the main problem is that.
Okay, I think
otherwise it would already be there.
I think we need to go to the next talk. Thank you again, Thomas, and thank you for the nice words regarding the service at the HPC facility.
It is amazing. It is amazing, and that everyone, like a small company without a lot of resources, without a lot of money, can have access to Cyclone. So compare like a week, my programmer's PC was occupied for a week to produce some results, and if something was wrong, then we need another week. So with the Cyclone, everything it's much easier, more accurate, faster, and the service, the support, of course, is amazing. Thanks a lot, guys.
Thank you, Thomas. Let's move to the next talk by Daphne Dimitriadis from Hyperion. We also have a project with Hyperion, and Daphne will talk more to us about it.
Hello, everybody. Let me see, can you see my screen?
Yes.
Okay, let me start the presentation. Okay, my name is Daphne Dimitriadis, and I'm the project manager for HIPOS. A bit about Hyperion. Hyperion has over 25 years worldwide experience in providing advisory services and implementing advanced manufacturing execution systems, or MES, as they're more commonly known, to the polymers, hydrocarbons, chemicals, and power generation industries. The mission of Hyperion is to become the leading provider of value innovation solutions to propel the polymer industry to achieve high level of circularity, sustainability, and profitability. As you can see below, our clients are all prominent players in the global plastic market, such as Dow Chemical, SABIC, ExxonMobil, Borouge. here you can see the plants we serve and how they look like in real life. They look like a Christmas tree, more or less. Now, what is HIPPOS, the project that we're doing with the Cyprus Institute, all about? I don't know if any of all of you know what polymer production is, how plastics are produced. Plastics, the raw material for plastics is polymer. And polymer production has many, many challenges. One challenge is that it is a continuous process, which means you should imagine a continuous process like, for example, when you open a tap of water and it's running. It's continuous. So polymer production is something that is continuous. It's not discrete, like you're building a car where you have one piece and you move to the next. So when you have an order to execute in the plant, it starts and it continues. And at the very end, it becomes a batch when you put it together and to put it into a batch to send it off to a customer. Now, this means that when you need to trace something, it's very difficult with the available solutions at present. And a typical production cycle takes many hours to complete. So when you start to create, perform an order for a client in this process, continuous process, a cycle can take maybe 4 to 12 hours to complete, which means there is delay in quality checking and therefore decision making. Significant of specification production leads to quality giveaways, and there is a lot of waste of resources, which means there is significant greenhouse gas emissions that go up in the air when you create, a polymer that has to be wasted. And there are many strict environmental legislations in place because polymer production is a very, very heavy industry. Now, having said all this, I want to say that there is a problem when something goes off spec. First, you don't know it, which means that it can take a whole production, make a whole production obsolete. And if it does become off spec, you cannot really sell it to the customer. So this has a very big impact on a plant in terms of profitability. And it also has a very big impact on the environment because this amount of polymer that has been produced takes up a lot of energy and emits a lot of greenhouse gases. It pollutes water, and therefore it is very bad for the environment. Now, our value proposition for HIPPOS is that we're building a toolkit that will provide an online decision support tool, which will help all these huge heavy industries in polymer manufacturing to save energy, waste, and water reduction, while enable improved quality and increased profitability for each of the polymer plants. And this is aligned with what is now the key, and if you like, the buzzword around everywhere in Europe, Industry 4 strategy and the Green Deal. Now, having said all this, if you are now a polymer plant and you don't have HIPPOS, which is our innovation, in the traditional approach, as I already explained, you cannot take corrective action until a very late stage, and you have created a lot of waste. With HIPPOS, as you can see below, you can take corrective action at any stage of the manufacturing process, and you are able to save and produce less waste. So, to give you to go into the nitty-gritty of the project, this is what happens. This is what you see a part of the actual plant. And without HIPPOS, you can see nothing. As you can see, it's all gray, and you have no idea what is going on inside these silos. With HIPPOS, you can now be able to see the material that is being sliced or discretized. And you can also see that there is green and red. And this is where the innovation of our project lies, in the fact that we can discretize a manufacturing process which is continuous, and assign quality bands to help people make decisions. So what we're seeing here and how we do it in practice is we are basing HIPPOS on the digital twin concept. Again, this digital twin concept is an Industry 4 concept, which means what? Basically, we model the physical plant and we reproduce the manufacturing process in a digital form for desktop viewing. And here you can see a small section of this digital twin. So the digital twin basically tracks material and quality data from the production equipment and is synchronized using values from the production process. Here, you can see how we convert this continuous process to this discretization that I mentioned, and where we come in with the Cyprus Institute is we use artificial intelligence now, which now you can see what happens, to assign quality values to the material as it is being produced. These values are tracked as they pass through the whole production equipment in real time. And these are visually categorized, as you can see, green and red, to help plant operators divert the off-spec material to separate silos so that the good quality polymer is not affected. And in this diagram, you can see the red is being diverted to the bad silo. So the red band that is approaching is visible to the operator, and he will be able to divert it to the red silo, so not to put it into the other green silos and affect the quality. And this artificial intelligence, which is now being developed with machine learning, is using a lot of data from our beta test customer in Greece. And as Nikos, I'm sure, will tell you, it's very, very challenging to be able to infer with the sensors that they have in place, the quality of the material as it's being discretized. Now, what are the benefits from this? HIPPOS plants will increase their differentiation and competitiveness, offering a solution that will bring substantial cost efficiency to the bottom line, reduction of off-grade products, increased revenues, and reduction in what is called grade changeover time. With HIPPOS, this leads to lower levels of consumption and carbon dioxide emissions, less off-grade product, and therefore helps transition to more sustainable manufacturing process. And HIPPOS will help plants achieve their sustainability targets, which could result in the reduction of 4 million kilograms of carbon dioxide per month per plant. And I can tell you that this is a lot. And the last benefit that we provide with HIPPOS is the fact that most of these huge plants that you have seen have bespoke solutions. These are solutions that basically were built in-house, that were built over time. And with the new challenges and technologies and the regulatory changes, we believe that we will bring a lot of added value to these big companies, these operations. And this is what I really have to say in a nutshell about HIPPOS. I will unshare my screen now, and I will put myself so you can see me. Can you see me? All of you?
Yes.
Yes. Okay. So basically, I put a very top view of what we are doing because it's a very, very difficult concept, I think, for people to understand. And it's also a very innovative project in the sense that nobody has done this so far anywhere in the world. And with the Cyprus Institute help in creating this data, using this data set to predict and find the bounds and everything, it will put us on the world map. So Nikos, if you want to say anything, if you want to be more technical, because you have been number crunching, I think I gave an overview of basically of the, what is the scope of the project. And I think maybe you would like to say a bit more on the machine learning side.
Certainly, and thank you very much for the very, very interesting presentation. I mean, all of your clients and your projects are very, very significant projects. So also the machine learning part is very challenging because it has a huge financial and environmental impact. So at the first sight, it is very challenging. But it is also challenging computationally because it is a time series problem. Actually, we are trying to predict the quality of the material ahead of time. So by nature, time series and particularly multivariate time series, because we have a lot of variables affecting quality, is a very challenging problem. But it is not only this, it has also some other computational sensitive points, let's say, how we treat time series, because they are not all measured in the same time lags, at the same time lags, they are on irregular time lags. So we apply, in collaboration with Daphne's team, we are trying to apply very sophisticated and tailored methods to this particular problem. And I guess that we already have some initial results. We are very happy about this. We can predict with some sort of accuracy the quality of the material, like before 15 or 20 minutes. So we have a prototype now. That's all. In brief, it is very challenging computationally and also very interesting from an industrial point of view and an environmental point of view.
Just to finish on this, I just want to say that I think I didn't mention this, that we have applied for an intellectual property to patent this. And we are pending a patent from the US Patent Office, the whole of the HIPPOS concept. And obviously, it's great that you will be contributing to this. So it's something I forgot to mention. I think everybody should know because not many. Well, first of all, it's a heavy industry. It's a very fascinating industry, the polymer industry. And although it looks like a Christmas tree, the plants look like a Christmas tree. They're very backward. I think if you look at their technique, how back they are not forward in the technical knowledge. And there's a lot of room for people and software companies to come in and bring them up to level with other industries there because they're huge. It takes a very long time to make such installations. It could take, in some cases, 1 year to make such installations, although HIPPOS is one of the advantages that I wanted to say is that we are able to do it in 3 months. And in Greece, where we did it for the Hellenic Petroleum as a beta test, we did it during the COVID, and we did it remotely. And this is a great first as well, which I also wanted to say and share with people. So basically, this is what I wanted to say. And it would be great if we, together with the Cyprus Institute, managed to penetrate such a heavy industry, the heavy industry, or from such a small island. That's all I wanted to say. And it's great that we have you and you're here and your brains and your support.
Thank you very much, Navi, and thank you, Nico, as well. I just want to have one last question, if you know, Daphne. So you talked about off-spec material, so material that does not meet the quality standards you want. So it's very costly for the industry. Do you have an estimate on that?
Well, it can sometimes. It depends. I mean, if I have some numbers, but they're confidential because they were given from plans. But I mean, this can rise to 100,000 euros, for example. I mean, we're talking about huge masses of production. I mean, these plants, I have never been to these plants, by the way, because of COVID. But, you know, people from Hyperion have been within the industry for 15, 17 years. You even have to take an internal car to drive down the production lines. You can't walk, they're so huge. And the production of these pellets that I showed you in the beginning, which is the raw material, I mean, you may have an order that may be God knows how many metric tons. So, I mean, we're talking about huge amounts of money. And another thing that I have to say is that in the European Union now, all of you hear about this Green Deal and about the sustainability thing. There is all these big industries have to buy what is called carbon emission licenses. And if you exceed your license per year, then you can buy from somebody else, which is maybe hasn't used them. And there is a price. These are traded over the market. So, for example, now, if you exceed your emissions, it can cost you, because you have to save on greenhouse gas. It can cost now thousands and hundreds of thousands if you're not careful with the gas emissions. And if you look at the latest report of HELPE, which is the Greek Hellenic Petroleum, it says its biggest impact was the greenhouse gas emissions payments it had to make to the European Union, because it went over its limit. So there are huge impacts with HIPPOs. I mean, it's a very smart thing to be able to divert this into the quality into waste, red silo. It's unbelievable. And so we are hoping that it will take over the whole world.
Thank you, Daphne.
Okay.
And yeah, it's quite exciting. I hope the project goes well. We have a hand by Rafael. Rafael, do you want to ask something? We have.
Yeah, just a quick question. Before, when you were talking about the silos and how we are dividing them into smaller slices, first of all,
it's the material that is flowing. Imagine that's the water flowing, and we are able to virtually
divide into slices. Yeah.
Yes.
My question is, first of all, do we assume radial symmetry for the whole silo, or do we have multiple sensors per slice? And the second one would be, how many slices do we have per silo, or does that just change depending on the size?
Rafael, I'm not the right person to answer the first part, but I can tell you about the second. The way it's sliced, we don't take the silo and we say, you know, it fits 10 slices or 20. There is another algorithm behind that. These slices that I showed you are based on what they call quanta, and these are the little particles that are taken through the algorithm.
Okay.
And they sort of segregate them, and they make the slice. So one slice can be, it doesn't have to be the same width or the same, it depends on how it comes through the algorithm, and it's not uniform all the time.
Yeah, you know, it depends on how much the material is mixed, basically, and the fluid.
Yeah.
Thank you.
Thank you again, and thank you, Rafael, for the question. I think we need to proceed to the next talk.
Pleasure.
Thank you, Daphne. Constantino, are you in the audience? So we have Constantinos from RetailZoom.
Yep.
One of the very big players in the field of retail in Cyprus and
You
Europe.
think?
I think so, and let's hear more from you.
Okay. Hello, my name is Konstantinos. I'm leading the statistical department of RetailZoom. I'll try not to take too much of your time. Let me switch the, should be visible now. Yep. Okay, so what we did is I will try to explain how the HPC helped our company develop and how basically it kept us in the market for all these years. We started around 2010, 2011, slowly, and our main focus was on big data. The reason I've put this slide is not to highlight what we did, but basically to show the things we needed to adapt in the company in order to make sure we survive. So the most important thing for us using AI, machine learning, and high-performing computer is the fact that we are still able to perform in this high level. I was thinking maybe this is the slide that shows how the HPC has affected our industry. Since 2010, we've managed to gain presence in 21 countries. So if we hadn't managed to accommodate all this data starting from Cyprus, which was our research basically environment, we wouldn't be able to handle data in bigger countries. We have clients in Europe now that basically handle the data that we have for all the supermarkets in Cyprus. So one of our main industries in Cyprus was the retail sector, and we handle now, as we speak, all the hyper supermarket transactional database on a daily level. So being able to live and compete in such changing environment has also helped the company not to maintain its presence in Cyprus, but also to develop the analytics abroad. One of the things that I wanted to share, and I took the picture this morning to show you, is how things changed. If I go to this slide first, how things changed since we started. This is an actual photograph of the data for Orphanidis. Orphanidis was the biggest retailer in Cyprus at that point. So when I actually went there to get the data, they gave me a CD with all the data, and I was actually, thinking that maybe this is the trend in Cyprus now. And I went and bought all these CDs because my aim was to cover the whole market. So I was thinking, if this guy gave me CD, imagine what the rest will provide. And actually, this was 10 years ago in Cyprus. It's not an exaggeration to say that in these last 10 years, we even seen our own process develop not 4 times that you mentioned before in terms of companies, but we used to handle one category, process one category from the FMCG industry, and we used to do it in SaaS, and it used to take 38 hours to process one category, which you can understand it's impossible to function. If that was the case today, it would definitely be closed by now. So slowly we managed to get 100 categories in 24 hours, and now we process 206 categories, which is approximately not very big, but for Cyprus it's quite a lot. We process 10 gigabytes of data from all the retailers. It takes 6 hours, and we manage to apply price correction algorithms on the data, to do outlier detection, clusters, aggregate, process the data, and present it to all these clients. Now, what is for us HPC? What does it give us? It basically, okay, we understand the aggregation of computing power and manage to handle this huge amount of data. But one of the biggest concerns for us is that we managed to solve problems that we couldn't in the past. Although we had the idea how to do it and how to go forward, taking days to process, and when we are running a PC for 40 hours and expecting to give you a result, you have all sorts of different issues that you cannot imagine at the beginning. A small change in the whole power system can shut the PC down and you have to start all over, and so on and so forth. I remember the first time we processed, I was going on vacation and we processed in 2013 a database and we published to the customer. And we found a mistake and we actually had to go back and rerun for a simple aggregation mistake. We had to run the whole database all over again and wait 2 days to publish the results. Another thing that we got from this big data analytics and we are able to analyze all this data is to capture as much more data we can. So we started off, getting the transactions from supermarkets. What are the sales? But at the end of the day, we now gather marketing information from different places. We manage to get the costs, the accounting. So we bring this all together, and this has been the evolution of the industry in Cyprus in the last 5 or 6 years. So the technology has given us the power to make these changes, and being able to support all these people in the industry quickly. The short time to insight is very important in our environment. So imagine if we are estimating the probability of someone like you to visit a supermarket the next month. So we have churn and risk probabilities. Usually we get the data by the end of the month. We calculate probabilities, we send them back to the supermarkets, they do their marketing campaigns. So by the time they reach you, it could be a month later. So we have already 1 month lost in order to get back to the actual customer that has a high probability of leaving. So by bringing this time closer to a day, basically, by being able to publish quickly what are the concerns for every organization and how quickly they can adapt to this, it has given the users a lot of flexibility and a lot of freedom on the things they can do. They have managed to increase their revenue significantly, and of course it has helped us a lot to compete in other countries as well. Basically, I think without HPC, we wouldn't exist as a company today. Going back to in 2015, I remember when we were thinking about investing in a BI tool, a business intelligence tool that would basically present our data. We were very good in inspecting, cleaning, transforming, modeling the data, but the presentation, imagine if you are publishing recommendation algorithms for the whole market of Cyprus. We are talking about 300,000 people, and you want to publish what is the next best product to buy. If you give that in a text file, or if you take 2 months to process that file, you definitely lose the advantage, and automatically you lose the client. So this big data, it's only getting bigger. It's not getting smaller. So another, let's say, concern I always have is when moving on to another country, whether the machines we are using will be able to support that. And we see that every year we take the next step. We manage at the end of the day to adapt to this new environment and model the data, present the data, process the data. So in 2010, our concern was Cyprus. Now our concern is going to Serbia, Romania. We're talking about populations with much bigger databases, so that performance has given us a very big competitive advantage. A very good example that we have seen in the industry is when you spend a month to provide a model that is 90% accurate, and the competition spends a day to provide a model that is 85% accurate. We've seen that 99% of the times the market will go to the model that takes a day and it's 85% accurate. So although speed is not the most important thing, being able to handle this data very quickly definitely gives you a competitive advantage. Another thing that I haven't mentioned and I haven't seen, because when we see about why using HPC and we read about all the multiple processes and how effective it is and so on, another big advantage that we gained is that we managed to accommodate our mistakes. We do a lot of mistakes when running models and algorithms, and maybe not mistakes, but probably back and forth calculations and processes. So if you have a process that instead of 40 hours, it can last for an hour, you can go back and forth 40 times compared to what you could 10 years ago. So even if we process something that is not complete, we manage to gain an advantage when we call the client and say we fix it. We fix it in just a few hours, whereas before it was an issue of taking hours to reprocess and redo the same calculations all over again. This is an example, and to close with, one of the tools we developed, which basically is a data detective algorithm, is a spotter algorithm that detects outlying behavior. So imagine that we have to load data for a supermarket or a cosmetic chain or a healthcare industry or whatever that the project is, and we load data for 2-3 years. We sit with the data scientists, data engineers, we fix the database, we run the models, we do the clustering, and then we need to publish something. If you are not able to publish and republish and present the data in a way that it's quick, and now when we are talking about quick data, maybe not all companies are not to the level of hourly updates, but at least daily. If you cannot publish overnight the results of the previous day or half a day with actionable results, then more or less all these analysis that we made is basically useless, because there are companies that they really need to use the data in real time. So this has given an advantage of how we can further take this analysis to the next level. I also had some concerns when competing with companies abroad, and we've seen that if I go back to the slide at the beginning, by going to all these countries, okay, so if we have a client in Serbia or in Romania or in Lithuania that buys data from Cyprus, because these data are all operated from Cyprus, it means that we have something better than the competition. So these guys are not actually stupid in terms of, I like Cyprus and I want to invest. So that for us is another proof that when we are talking about HPC and what the rest of the countries have done and what the rest of the companies, and we're not talking about Google or Microsoft, But we see that, at least in our industry, we are still competitive with a lot of countries, and we are getting projects every year. So if I was to conclude with something, is the fact that I honestly believe that we wouldn't exist as a data-driven company if we haven't invested in this technology. And I can say that from the overall investment we've made and the money spent all these years is the least cost that we could invest, in all the things that we spend our money on. That's it.
Thank you very much, Constantino. I made a mistake before. I said about Cyprus and Europe, but it seems that you're exploring more than one continent. You mentioned
yes,
4, right?
We are in 4, yeah. We got some projects that, because the clients are multinational, basically, so if you get a client from one country and they have services in different countries, it's easier to navigate and get the same project in, because once you do it in one country, then it's more or less the same.
Yeah, exactly. Yes.
Christo, can I ask?
Of course, Nico, go on.
Thank you, Constantino, for the very interesting presentation. I would like to ask you if you could tell us some more things about our project we started on recommendations and how challenging it is computationally and how useful it is for a retailer to use such algorithms.
All right. So basically, the project is to be able to recommend products real time to people buying from a supermarket. So we are talking about, I don't know what is related to the rest of the industries, but quite big amount of data. We are talking about tables of around 500, 600 million proposals. So for a customer, you might have 50 or 100 products. If you consider that a supermarket has 35,000 products active in 1 year, imagine the proposal we can make in a single day. So the project aims to, we will try to rewrite the recommendation systems for all the retailers in Cyprus. We will try to create an API through which they will be able to link their database in order to get real-time recommenders for the products they want to push. So basically, there are 2 aspects that we need to tackle. Of course, the first one is to provide good recommendations. So the algorithms that we will write, they need to be making sense. And unfortunately, there is no easy way to check whether they make sense, because they might be making sense when viewing the results. But if you don't test the output on real people, it's difficult to conclude whether they make sense. So this is something that could differentiate us from the competition. As you know, all companies have a recommendation system. So the one that has the most accurate and can generate the more money, it will definitely be preferred. And the second thing is to be able to seamlessly link the database of these retailers, whatever that is. If they have an online shop and they are a supermarket, if they have an electronic shop, if they have a clothes store, to be able to link the data through an API to the recommender system and publish real time when somebody logs in or viewing the website, to show recommendations of products, of whether to uplift, cross-sell new products, and so on. So the project again is quite demanding. The good and the bad thing is that there is no actual threshold to compare to with the recommender system. You can only be judged if people like it and if the turnover goes up. So hopefully we will do a good work prior to that in the next few months with Nikos and the guys, and we will be able to publish something quite relevant. Right, Nico?
Yes, thank you. Actually, this is the case because there is no golden algorithm for recommendations, and of course you have a very, very big experience on this. It is you should tailor the algorithm for the particular problem, so it's quite challenging to generalize an algorithm and have something working on a general database.
Yeah.
And I guess also the benefits for the stakeholder are quite big to have such a system on.
It is, and that's what, you know, one of the things we get when we show the slide. We are in 20 countries. The first question is, okay, which companies abroad? And we say it's the same Cypriot company, and they are all saying, you know, who bought you, who built this. So it's actually a very good advertising for Cyprus and for companies like us to be able to say that in 10 years we managed to do that, and there is this knowledge internally, and I mean in the more general environment of Cyprus to be able to do these things. For us, it's you know, it's something we must do. Otherwise, like I said before, it's going to be over before we even start.
Mm-hmm.
Thank you again, Constantino. Yeah, sure, it's the recommender systems is surely not only an exciting topic area, but yeah, it's one of the most challenging ones. I guess together with forecasting with time series, and hopefully the project goes. Hopefully the project is successful. And
it will be. There is no hopefully. So we have a lot of people involved, and it will be, right?
It will be. It will be for sure. All right. Thank you again.
Thank you.
And let's proceed to the last talk for today, where we will have Andreas, who is a scientific coordinator at CaSToRC, and is going to briefly discuss with us about funding opportunities for industries.
Yes, hello everyone. Let me just share my screen. Okay, can you see my PowerPoint?
Yes, now on presentation mode. Yes.
Yeah, perfect. So you can see the screen, not the display mode, right? The full screen.
Yes.
Correct.
Yes.
Okay. So hello everyone. My name is Andreas Gavrilidis. I am one of the scientific coordinators of CaSToRC, and it is a pleasure to be here to present the Horizon Europe program in a bit of detail, and especially focus on funding opportunities for SMEs, local SMEs that are presented. So to start, I would like to just show the multi-annual financial framework that was approved by the European Commission. So this is the final numbers for the 2021-2027 program. Of course, this will be split in various funding periods. So it's a biannual, actually, work programs that we're going to see. So for now, we have the 2021-2022 work programs, which we will analyze further, and we will be waiting to see what are the allocated amounts each time, depending on how many projects are being funded and so on. So as we can see, the European Commission started funding programs since 1984 with the FP1 framework, and since then it has evolved from 3 billion in 1984 to 95.5 billion for the latest program, which is also a significant raise since from even the Horizon 2020 program. So it is the world's largest funding program at this point for research and innovation. This budget now will be split in this manner. Well, the numbers may vary slightly at the end of this program, but as we can see, a very large amount, the biggest one, more than 50%, is actually allocated to global challenge and to increase the European industry competitiveness. So that means that for the industrial partners, this is a very important actually fact for this program. It is much more prominent in the Horizon Europe than even in Horizon 2020. And this is shown especially with the descriptions that we're going to see further and with all the clusters and the new, but let me not run ahead of myself. And of course, we need to pay also attention as Cypriot, as part of the Cypriot ecosystem, we need to pay attention that 3.4 billion are going to be allocated in the widening program, which is for countries with a low research and innovation potential, not potential, with big potential but small applicability at this point, to fund for us to be able to be more competitive with the larger European countries such as Germany, Austria, and so on. So the program will be structured as such. There are three major pillars under which the majority of the program of the proposal, of the cost of proposals are allocated. Of course, taking into account the widening programs, plus some specific programs. For the first time, we have an exclusive European Defense Fund, which is split into research and development actions, which is focused primarily on applying dual technologies. As I see it, it will evolve to that, like dual technologies from application from AI to unmanned aircrafts, better defense systems in general. So it could be something that potentially some people may want to shift towards too. And the Euratom program, which is continuing from Horizon 2020, dealing with all sorts of nuclear programs, including fusion, fission, and joint research centers on atomic technologies. So from the three pillars, we will focus more on the Innovative Europe pillar 3, which also includes the European Innovation Council calls, which I guess some of you may already know. But we'll also pay a large attention to the pillar 2, which is the global challenges in European industrial competitiveness, which obliges academic partners to seek industrial partners and vice versa, to form both joint research centers and contribute to the big challenges as identified by the European Commission, including the clusters, which we will see in more detail moving along the presentation. Along with the three pillars and the whole structure, Horizon Europe seeks to synergize with other union programs, most notably Erasmus+, the European structural funds, the life programs, the single market program, innovation funds, and it seeks to harmonize various funding rules and give to industrial and academic entities flexible co-funding schemes, which will lead to more maximum absorption of the available resources at the European level. And of course, helping all of these programs to unite for seeing like a common path, a common vision towards achieving certain European priorities in this 2021-2027 framework. So I will briefly stay on pillar 1, which is excellent science, which includes the ERC, the ERC work programs, the MSCA, Marie Curie actions, which are basically also a way for industries to get involved, because in these specific work programs, the European Commission envisions not only purely academic joint doctorate degrees, but industrial doctorate degrees, and give incentives for companies and SMEs to participate as industries and SMEs to participate as secondment organizations, making sure that the scientists of tomorrow have some practical experience, and giving industrial entities the chance to absorb directly researchers. And of course, the development of research infrastructures connected both European and the in the US, China, the rest of the world, connections between different infrastructures, and thus increasing the capacity for research and innovation in the European landscape. So Pillar 2 it can be divided between, as we said, the clusters, which are 6 at this point. We have health, culture, creativity, and inclusive societies, civil security for society, digital industry and space, which is actually the biggest and most funded cluster, with close call to the climate, energy, and mobility cluster, plus the food, bioeconomy, natural resources, and agriculture and environment. And of course, some joint research centers which are not nuclear related, such as, because Euratom will take care of that. So the total budget allocated in this 2021 and 2027 is 53.5 billion, which makes it actually the largest amount from this budget allocated to this pillar. So I will go quickly through the different clusters. Health cluster has the aim to promote and protect human health and disease prevention, which was even more prominent with this COVID-19 crisis. There is extra funding going to be allocated. We're still waiting to see the numbers on that. And of course, the transformation of healthcare systems throughout the whole cluster, the whole work program. This is not, again, I repeat it, this is not an academic effort only. It is, it will include all the stakeholders, and there is a lot of opportunities for transition, even from an existing business model to something new, or create a large consortium that has a bigger advantage. Cluster 2 is culture, creativity, and inclusive society, looking to fund different initiatives that aim towards a more democratic governance and participation of citizens, and in general, civil and civic engagement, and better access to cultural heritage programs, which might also be interested for companies who are into using data science for visualization and different digital cultural heritage projects. Cluster 3 is civil security for society, which is geared towards cyber security and cyber protection of citizens, as well as external threats. Not to be, this does not include the defense fund. That is a different array of projects. This is actually from internal, if someone would say internal damages, such as natural disasters and cybersecurity breaches and so on. The digital industry and space, I think this is where we'll be mostly concentrated. We'll see many calls that are geared towards advancing digital and space technologies, digitization and transformation of the European industry, as well as contributing to a low carbon, circular and clean industry. This is very clear what Europe wants to, what the European Commission tries to achieve. And this is, I believe, a large part of what we're going to be able to contribute through our participation to this program. The climate, energy, and mobility, so I think it's a bit self-explanatory. It's to fight climate change and making more energy efficient and reduce the overall environmental impact on a European level. Cluster 6 has to do with expanding the capacity of sustainable management of natural resources, and of course preventing and reversing, if possible, what is very obvious in the last few years, that all of the ecosystems are being degraded and many species are going extinct. Hopefully reverse and also, of course, reduce pollution on a European level. Pillar 3 is what we call Innovative Europe, with a budget of 10.6 billion, including the New Generation EU, which is the recovery fund dedicated to the COVID-19 crisis, is where we're willing to help every industry to participate with. It aims to bringing all the key figures, key stakeholders to create a common goal of making breakthrough innovation and increasing the innovation capacity of Europe and reaching other like the levels of the United States and so on. We have the capacity to achieve much more than that. So this is something that I believe it's which we will analyze further in the presentation. So so far we have the 3 calls that will be open for the 2021 work program. It's been published. We can share it with you. So the European Innovation Council calls are split into 3 big calls. The Pathfinder call, which is for technology readiness level 1 to 4. The transition calls, which are from TRL 4 to about 5 or 6. And the accelerator calls, which are for a TRL 5 up to 8. Plus some prizes that are going to be awarded each year, and special nomination criteria apply. The programs are released on how someone can be nominated for such calls. So this is the scale that the European Commission uses to define TRLs, and this is how they will expect people that like entities that apply to these 3 calls to evaluate themselves. So TRL 1 starts from that we're at the basic principles level up to a validation of our technology in a laboratory environment, in vivo or in vitro. Then moving to transition is the company, the industry that wants to take the laboratory tested technology and demonstrate it into a much larger relevant environment before releasing it to the public. And from 7 to 9, we have actual production towards providing to the consumer or to any group that the industry is interested to do so. This is just indicative. I just took a small part from the open calls. We're always at your disposal to help you with figuring out where you might be able to apply, help you with applications. Yeah, please, we will be in contact, I'm sure. So apart from the European Innovation Council, we have what we call the European Innovation Ecosystems, which aim to create connections between various industries and create larger entities that will be able to support the scaling up of companies to develop even further innovative solutions through cooperation and address solutions necessary for any economic recovery, environmental sustainability and resilience, thus connecting it to the previous clusters, as well as aligning with the European principles, let's say. A driver for all of this is the European Institute of Innovation Technology, EIT, which is basically in charge of developing knowledge and innovation communities, which are supposed to bring together businesses, research centers, and universities under a common umbrella and cover what the European Commission envisions as its innovation chain. So we have the EIT climate, digital, food, innovative energy, health, manufacturing, raw materials, urban mobility, and the launch of 2 new knowledge and innovation communities are foreseen in 2022. As you can see in this presentation, these are just indications. We're not sure if we will be able to see them in 2022, but this is something that I believe would be beneficial for us as Cyprus to have a strong participation in these communities, to be able to advance our own goals as a country, let's say. And I believe that there are initiatives starting to be developed by the with governmental support as well. Finally, a small introduction to what is the widening participation. I will not go too much into it because I think we're also probably running out of time. So I will just move along and just let it hang a little bit here. It's yeah, to that we can discuss in future presentations in more detail. These are some of the projects involved in this widening participation work program. Teaming, which are multi-million euro projects aiming to complement the country with new research centers and promote this research impact on the country. ERA chairs, as we discussed, we had Vangelis Karamandaris, who is an ERA chair at the university at CaSToRC, at the Cyprus Institute. Cost actions, I'm sure many of you are familiar, and so on and so forth. Yeah. So the 3 types of actions, as you may well know, is from the Horizon Europe, from the Horizon 2020 program, are the research and innovation actions, which provide up to 100% funding rate, innovation actions, which provide up to 70% funding rate, except for the non-profit legal entities where a rate up to 100% applies, and coordination and support actions, again, up to 100% funding rate. I would like to just put a small asterisk. The actions under the European Innovation Council do not fall into the innovation actions category. So there are 100% funding schemes for SMEs and industries. Keep in mind, I want to just put it here, that the main evaluation criteria while writing a proposal are excellence, impact, and implementation. These are the biggest focus that a proposal should have. This is a small timeline of how to, from submission to pre-financing. Open science is also a priority along the board. We need to be able to manage these new initiatives of open science. Of course, seeing that the industrial partners will want some confidentiality, it is not on an absurd level. So there is this phrase, as open as possible, as close as necessary, for the results produced by the industrial partners, which, of course, it is a consortium-wide issue. We will, given that there are academic partners, this will be something to be taken care of by everyone and not be handled single-handedly handled by the companies. Gender equality, of course, is something that will be, gender equality plans will need to be based in all entities for their participation to the Horizon Europe program after 2022. Yeah, these are some what we said before, that some rules and some examples of how do we account, how do we budget for an action. So moving to the European partnerships that we discussed before. some of the key features of these partnerships is like they need to be geared towards a single strategy, like have strategic orientations, a systemic approach with a simple architecture, and a common set of criteria for the life cycle of these partnerships. These are under some clusters plus the EIT pillar. We see that there are some established by the European Commission, such as taking ERA for health from the health cluster, cluster 1, circular bio-based Europe from cluster 6, clean hydrogen, and so on, plus what we discussed before, the knowledge and innovation communities. So this is something that we look forward to start and be able to be part of it, hopefully. Complementary to the work programs and to all the new structure that we saw before, the European Commission has set some missions forth, which is actually a portfolio of actions to be able to have a big goal and a big impact for society and policy making. These 5 missions are the adaptation to climate change, cancer, healthy oceans, seas and coastal and inland waters, climate neutral and smart cities, soil, health and food. These are what we call the European Bauhauses are currently open calls for these demonstrators in this European Bauhaus for each mission. This is a small how to access the funding and tender portals in order to be able to see more info and more details on what program, on what calls, and what the work programs have as details through the European funding and tender portal. Following from that, I wanted to focus on what the European Commission identified that was holding back European innovation. So it was an issue with innovation performance, lack of breakthrough and disruptive innovations, lack of innovation funding. There was a big gap between research and development grants and private investment for scaling up startups, and a problem in the innovation ecosystems that were fragmented at the European level. So they existed at the national and local ecosystem, but not at the European level as one. This is what we're trying to mend, to make better and more cohesive. This is a small graph that I liked, that I really liked, and then sort of took from some economic analysis that was done as part of the Commission's report, which is where we do have a lead, where we are where we led, who is currently leading some of these sectors, and what the future would bring, and how we need to be on the forefront if we want to achieve dominance in the innovation space. These are some numbers that from 2007 until 2016 that showed exactly how big we were lagging, how bad behind we were from the United States in terms of venture capital raised in both let's say entities. Yeah. So as I said at the beginning, I want to focus on the European Innovation Council because I believe this is where we'll be able to target as we are now, as we discussed. So the European ecosystems, tech ecosystems, are by themselves rich, but they can only reach their full potential if we manage to connect between the different countries at the European level. So what does Horizon Europe propose? It proposes funding in 3 large areas. In open science, which is achieved mainly by Pillar 1, industrial competitiveness, Pillar 2, and innovative Europe, Pillar 3. So how does that translate in the European Innovation Council, and how does each call that we analyzed before connect with each other? So the Pathfinder call is to start from ideas that lead to startups. Then the startups go to the accelerator so that they can be scaled up. In the meanwhile, the European innovation ecosystems can, using the European Innovation Forum and joint innovation programs, will start not only providing support, but making these companies grow as to be competitive in the not only national but European level. This will also be done, of course, through what we said before, the knowledge and innovation communities, using higher education, research and technology, business savviness from the stakeholders, from the participants, in order to help smaller players grow up. This is a small how the European Innovation Council is envisioned. It will be a one-stop shop, actually, for breakthrough and disruptive innovators that will provide also agile funding and build ecosystems and communities through its various goals and strategic orientation. The Pathfinder and Accelerator pilots are a 2.2 billion pilot package to support bottom-up ideas. The Pathfinder pilot is what many of you may know as what we call the Fed Open and Fed Proactive Future and Emerging Technologies, which will now be under the Pathfinder label, let's say, and it will fund around 160 projects, while the Accelerator pilot will has enough money to fuel 10 times as much through these initiatives. So a few words, when we say innovation ecosystems, how do we do it? We need to take the big players in each country and make sure that we support this complementarity between the EU initiatives and the national initiatives, and provide reforming policies to be able, and give the resources to be able to develop coordination and cooperation mechanisms between not only EU, but not only with member states, but also with the associated countries, and provide initiatives so that to every actor, both private, public entities, and any player that can boost this ecosystem and grow, help it grow. So the European Innovation Council has already been prepared for Horizon Europe. It is, of course, in collaboration with the member states in order to lead to a fast-track innovation, as it's called, and be able to provide and be able to set in place initiatives so that co-funding from governmental and European entities can give the required capital for increasing this potential of EU industrial players. This is some in sort of an infographic, how this is envisioned. The research and innovation missions of Horizon Europe has to do, as we said before, with giving maximum impact in the hands of European industrial players. And this is the areas for possible partnerships. It's a more visual. I like the visual that was provided by the European Commission on how we can achieve this. What are the areas of interest? Okay, this is actually a little bit. We dive into more detail on what we said before. I think that can skip this for now. So these are some of the areas of each cluster that we could be a part of and help us create develop our key technologies and become bigger players in the European ecosystem. As we said before, the approach that the European Commission takes to open access is as open as possible, as close as necessary, but without forgetting the FAIR principles and any other open science practices. We need to create a sustainable ecosystem, and this is something that will be very prominent in the new rules on how to apply for a grant or a fund and for funding, and thus we're still waiting to see how the first few calls will evolve. What will the lessons learned be from the initial applications, and then refine our strategy. This is a strategic planning process of Horizon Europe as a whole, and it is also, as we said, to enhance synergies with other EU programs, and part of this is also the update, the revamp of the funding and tenders portal, so that everyone can easily access any EU funding and project implementation needs they have, either to find funding or find partners, from that to even be able to manage their projects better. That we discussed. One of the biggest novelties of the European Innovation Council is the European Innovation Council Advisory Board, which is going to advise along to the Commission as the Horizon Europe program evolves, the design, on how the design should change, so there will be this kind of fluidity. Any mistake will lead to a better future step to support the innovation capacity of Europe. This advisory board is a group of 22 entrepreneurs, investors, individuals that are building startup communities, but including researchers and academics as well, working on policy, on innovation policy. And they have supported the Commission to develop the pilots, to enhance and the overall strategy that will be followed under Horizon Europe. Yes, so the Pathfinder pilot is what the Commission calls Deep Tech Made in Europe, which needs a strong research base. Of course, we never forget that the academia has a very big role to play in this, and we need to keep pushing for reaching new levels, being on the forefront of innovation at all times. Yes, as we said before, these are some of the elements of the Pathfinder calls. The European Innovation Council program managers will provide a flexible and proactive management for steering of the portfolios of these companies, and whatever is based on these challenge-based projects, I guess. And this is also one of the other novelties that were not seen before under any innovation calls. To apply for research and innovation actions under EIC Pathfinder, the page limit is set to 15, which is way less than which is reduced, not much reduced, but reduced from Horizon 2020 in similar calls. And each proposal can receive up to 3 million funding, with having a minimum 3 partners consortium from at least 3 European or associated countries. This is a small some paradigms that will be that were actually, let's say, on the highlighted by the European Commission, such as human-centric AI, breakthrough zero emissions energy generation, and so on. And this will keep showing up in the future programs, and this is going to be actually much bigger proposals, 30-page proposals with more funding, but again keeping the 3 minimum partners limit. Of course, environmental intelligence is also a big part of the EIC Pathfinder calls. There is going to be funding as well for innovation launchpads. So from turning results from previously funded projects into innovations that will have a real impact in society. So this is a smaller funding scale, which is more or less up to 100,000 euros over 18 months. This can be applied by a sole entity or as part of a consortium, and of course, the successful applicant needs to prove that they're capable of making a market analysis, technology assessment, make sure they treat the intellectual property rights, and so on and so forth. This is another type of calls for proposals, which is the transition to innovation activities, which turns any promising results into breakthrough and disruptive innovations. This is much higher, it will receive higher funding with a longer duration in order to bring these results into the market and after the end of the previous project, we will now move towards a TRL level higher than the one achieved before. This will have some target technologies in mind, which is micro and nanotechnologies, artificial intelligence and robotics, technologies for life sciences, which coincide with health and treatment, which are in the same level as cluster 1, energy technologies, interaction technologies with other clusters as well. So all of these are connected with each other, albeit not in the same work program, but we can easily see that a company applying for one doesn't exclude it from applying to the other, and creating synergies within the company itself and advancing their strategy towards new approaches in many different sectors. These are some indicative, these were the indicative, the definite end dates for the Fed calls, and which means after that, the previous calls, as we mentioned, started to take advantage of the results of these projects. These are some of the criteria, evaluation criteria for this kind of projects. Some novelties about the accelerator, pilots. So the accelerator blended finance, which would provide over 100 million euros in equity. It is targeted towards SMEs with potential to scale up, with the potential also for substantial support on the global scenery, and this concerns SMEs that that have an early commercial prototype and want to go to market deployment and scale up, which usually corresponds with a TRL 6 or above. Of course, exceptions do exist. It always depends on the applicant and the proposal itself. The pilot will also focus on building an SME instrument. It's a different call for proposals. In general, this is a high risk, high reward potentials for SMEs with substantial funding, which concerns the last stages of development. Say with a bottom-up approach, including not only products, but services, the creation of new business models, and grants will go between 0.5 to 2.5 million. And in this case, the funding rate is 70% of the total cost due to this high risk, high reward potential, with an equity option up to 15 million on a blended finance model. So these are the differences between how do we go from grant to equity and so on. These are the criteria. As you can see, there is an equal weight to all the criteria to impact excellence, as well as quality and efficiency of implementation. And of course, if the company has requested an equity component, they will be subject to due diligence, as stated by the program. This is the process, the step-by-step process of the accelerator pilot, starting from the submission of proposals, a remote evaluation, ranking, followed by an interview before signing the grant agreement, with, of course, in case of blended finance options, 2 additional steps: the due diligence and the equity investment. This is, of course, another novelty, and this is also reflected in the application, which is reflected. I don't want to go too deep now, because we will encounter these things in front of us for a long time, and I'm sure we'll have the opportunity to discuss it in much more detail. It's a 2-step evaluation. Step 1 being a remote evaluation, as with every other proposal, but also following a face-to-face interview with 3 possible outcomes: a go, no go, or change into blended finance decision. Due diligence, as we said before, it will be done by a special purpose vehicle, as it's called, and will focus mainly on evaluating the compliance and risk level, as well as confirming the investment amount and structure, the estimation of the total financial effort, and defining equity tranches and key milestones for the project. The equity investment will have, actually, if they gear towards an equity investment, they will be structured by a separate agreement. This equity investment will have a passive role in the daily management of the company, and an exit strategy will be offered in case of the consent of the company. Then the special there will be the instrument will seek actively private investors to buy the European Commission shares. These were some of the cutoffs for the accelerator pilots. FTI is also part of the European Innovation Council, the Fast Track Innovation. This is a fast-to-go market. This is limited to a consortium of 3 to 5 entities with an up to 3 million investment, with a mandatory industry involvement. The business acceleration services offered by the EIC pilots are for SMEs, for the European Innovation Council clients, for SMEs, which offers coaching, mentoring, a community platform, networking events to really support the growth and minimize the risk that such SMEs may face. I left it. I put in like a small success case, the body on a chip, from research to commercialization. This is a company called Insfero, and the praise of the FET Open program that allowed this company to grow. These are some of the European Innovation Council Horizon prizes, which award a company or an entity in general for addressing the various societal issues such as the gender equality component and provide any big societal solutions that any company that has applied an out-of-the-box thinking and so on. These were some of the previous prizes that were given to that were challenge-driven. For example, 10 million were awarded for innovative batteries for electronic vehicles, 5 million for early warning for epidemics, and these will continue to be offered every year as part of the European Innovation Council. These are some, when we share the presentation, these are some useful links for anyone who's interested to apply. This again is a small slide showing the technology readiness level from Europe. And Christo, how much over my time am I? I see I'm 20 minutes over my time. So the last few slides are dedicated actually to the general criteria that apply to any proposal. I thought it would be nice to give some general sort of tips and tricks, but I don't know how do the people feel? Should I finish with the slides, or we can share them and people can study them? I don't know. What do you think?
I think it's maybe good, Andrea, to wrap it up and maybe have a follow-up session or share everything in Slack as well and try to have a discussion.
Yes, yes, of course. Yeah, well, in any case, so yeah, Chris, I think you're right. So what I would like to end this presentation with is that well, this is the reason I took some extensive time to have it, because we're facing with a new work program. Everything is new. We have the experience carried over from Horizon 2020, but it's clear that we are facing some new challenges. There will be many opportunities for funding. CaSToRC, as a research center, as an academic entity, we are very willing to work with you, collaborate, and apply together for this. And we believe that we can have a mutual beneficial relationship. There is a way to realize all of our goals from our side and from your side, and that we look forward to contact you more, to have you as part of many consortia to come. And yeah, pretty much this is from me. And yeah, I'm open to questions if there are any questions or any comments.
Thank you very much, Andrea.
Thank you, Chris, for the opportunity.
For the, yeah, a lot of information and a lot of funding opportunities actually at the moment for this sector. If there are any questions, please go on. I see there are not a lot of people left, and thank you all of you that stayed until the end.
Thank you, everyone. Apologies for the long talk.
Well, the talk will be uploaded on YouTube as well, and you can get the information from there. We will share it soon.
Yeah.
So all the talks will be there. Okay. All right. Then I guess we can call it a day.
Yep.
So have a good evening, everyone, and see you tomorrow at the training for those ones that will come.
Yeah. See you. Thank you very much. Thank you, Chris.
See you. Thank you very much.
Bye.
Bye.
Bye.